Innovation Director for Zenzic. I want to just sort of reflect on a point from our Connected and Automated Mobility Roadmap to 2030. This lays out around about 500 milestones across society, legislation and certification, vehicles and infrastructure, as a pathway to deliver connected and automated mobility services by 2030. And there's a number of things in here, which we like to call critical waypoints within the roadmap, where a number of things come together in order to deliver something really, really, really important. And don't worry too much about the rather opaque naming on here. That's sort of necessary because we can't get all of the information into a simple diagram like this. But in the roadmap of yourself, if you have a look at that, there are keys to all of these things here. So what I want to talk to you about is a critical waypoint here. So that testing specialists define best practice. Okay, testing specialists define best practice. That's LR78. LR80, which leads on from this, is UK safety case adoption feeds into global standards. And this feeds public gain exposure to self-driving vehicles and feel safe. So ultimately, this point about testing specialists defining best practice has a direct link to public acceptance and the delivery of services to market. Now, what does that really mean? When we think about the options for verification and validation, well, we have a few, and I've sort of grouped them into three categories for now. And what we're going to talk about here is simulation, test at scale, test remotely, test risk-free. Very important part of verification and validation for connected and automated mobility services. Testing at a proving ground, testing in private, testing a complete safety, testing in a sandbox environment in real life. And in the real world, testing with users, testing with complexity, and testing your business model. Does it really work? I think these are sort of the vital sort of pillars for verification and validation of connected and automated mobility services, which we need to consider. When we think about simulation, one of my sort of favorite quotes is a little bit dated now, but from the RAND Corporation, that autonomous vehicles will need to travel 5 billion miles to demonstrate a 20% improvement in fatality rates at a 95% confidence level. It's just not simple, it's just not feasible to deliver the amount of testing and validation we want to do only in the real world. And that's why simulation, I think, as we all appreciate, has a vital role to play in delivering verification and validation for CAM services. And when we think about simulation, there's a number of things, a number of layers within that, which we consider as sort of emergent in the market as ways to test connected automated mobility solutions. Vehicle in loop, I think, is a great example. So how do we put hardware into the loop, embed it into a simulation, and enable to play data from that real vehicle backwards and forwards, across the CAN bus, across the radar and the LiDAR and the other sensors to test how does that vehicle perform in simulation. We're not just talking about gaming engines here. We're talking about taking the hardware to the simulation. And this example from Millbrook Proving Ground is a great example of being able to embed a vehicle within a simulation, have components within that simulation for radar, radar in and out anechoic chamber, offboarded from the vehicle, but yet still able to interact with the vehicle in here and receive messages, which are replayed from a generator, a radar system within that. So, this is a great example of emerging simulation capabilities. Let me think about, what about simulation from building information models? There's a lot of work being put into now into urban environments, into creating realistic models of how the environment is constructed, very detailed data models. And I think that the thing here from Smart Ability Living Lab in London is, the interesting part here is the elements in and around the glass on this bus shelter. Within a building's information model, you can specify the type of materials, and you could specify the properties of those materials so that as you conduct a simulation, using radar or LiDAR, you can try and mimic those properties for specific elements of the simulation. Very interesting way of potentially doing validation in a pretty advanced way, without having to have any physical infrastructure. And then we think about augmented reality. And this example from Myra Proving Ground, I think is really interesting. This is another element of one of our Testbed UK partners. And ultimately what we're looking at here is augmented reality. How might you have one or two vehicles being tested in a real world environment, but having other virtual vehicles working in concert with them within that test scenario? So how might we have vehicles within here, the two that you can see on the left of the picture, the Ego vehicle, which is sort of at the junction, and the van that's driving past. And then the two vehicles on the right of that picture are actually don't exist in reality. They are injected into the simulation, but perceived by the Ego vehicle as part of the test. And then sort of another trend, which I think is really interesting, is how do we make simulations more accessible to make these simulations much more deliverable within the market. And I think Go Momentum Station in the US has a great solution here, whereby what they've done is they made their facility, open source that, a free to use, simulation within that. You can download the models, you can put your vehicle in it, and you can live it in there. Now, clearly there's a business model thereby they want the simulation to happen up front, and then they want you to come to the facility and use the facility. That just makes perfect sense potentially. Other ways is to sort of accelerate development and look at new business models for attracting customers. When we look at proving ground testing, I think something I've observed over the last sort of few years, within the UK and across the world, is that there's a couple of trends. So we in the UK have been doing is very much a generalist to specific approach. So again, it's sort of Myra Technology Park. Those of you familiar with the facility know that it has, sort of a traditional sort of makeup on an old airfield. So it has a loop around the outside. It has a set of roads, in the middle of that loop, which enable you to sort of test, on roads that are recognizable, in a city. But what they are investing in, with the Centre for Connected Automated Vehicles, Zenzic and Innovate UK in the UK, is to create a parking facility. So they have a very general set of capabilities. Now they're creating something very, very, very specific to realize an opportunity in valet parking. So this facility, it will have a multi-story car park component. It will have, a regular sort of open car park. It'll have parking bays, and several other of these things, so that you can test very specifically different parts of a valet parking system in the real world. Another very specific sort of example from moving from a generalist to a specific set of capabilities is Cavway, sort of under construction in the UK. Partnership between a company called Prova and Idiada, Applus. This capability is very much trying to mimic what are the junctions on highways. So we have you can have a very generalized set of testing capabilities, but a very specific set of capabilities are being built at this facility for merge and demerge on highways in a safe and secure environment. When we look at this from an international point of view, actually, when we think about capabilities like K-City in Korea, I think there's a really interesting point about being able to move from what is a fairly specific to a generalist scenario. So, and this facility is a great example. It was built with Korean roads very much in mind, very, very specifically for urban and suburban driving. But actually, a number of elements of the facility actually potentially allow for much more generalist tests to occur as well. Equally, in Ottawa, sort of the Sandbox city of L5, this is sort of a large area put aside by the city of Ottawa to test connected automated mobility solutions for their city, to make sure that they can build on the economic success within here. And actually, I like this picture obviously because it has a Rego pod from built and designed in Coventry here. So great to see those in Ottawa as well. But this capability in Ottawa has a very, very sort of specific function for the city of Ottawa, but actually has the capability to grow in something more generalist and provide a wider set of testing and development capabilities. Just bear that in mind sort of when I come back to my call to the arms at the end of this presentation. And then finally, let's think about real world testing, that final pillar. The Smart Mobility Living Lab in London, again, part of Testbed UK, funded by Centre for Connected Automated Vehicles and Innovate UK. And this facility has 26 kilometers of roads, very accurately represented in simulation, very accurately sort of measured and monitored, with 5G, roadside units, cameras and things, so that you can test your vehicle in a real world environment. And this is probably, one of the live tests in Europe's only mega city, in London. Equally, what we've also invested in the UK is Midlands Future Mobility, which is 200 kilometres of highways, rural, urban and suburban roads. So again, lots within there for simulation of these environments, but also monitoring 5G capabilities, so that you can take your application and see whether it works in the real world. And you can, you have all the tools and the capabilities at your hand to see if your business model will function, because ultimately that's what this is all about, is delivering businesses to market much, much faster. And then we can't ignore the elephant in the room when we think about this, is it sort of China taking this to the next level. The Intelligent Connected Vehicle Public Test Road, so named, apparently 800 kilometers of connected and public test roads in China there as well. So, this is definitely a global trend to try and create these large scale living labs where you can take your product and service to market. Very important. So coming back to the options for CAM verification and validation, simulation, proving ground, and real world. When I was sort of working in defence sector, and one of my old directors, he'd say, the magic happens in the overlaps. And I truly believe that. So when we bring these circles, these pillars together and we overlay them, what we end up with is a set of capabilities that can be knitted together and work better interoperably than they do alone. And really, when we do this, we bring them together. Really, data is the glue that starts to hold these capabilities together and allow you to move between different capabilities. And ultimately, when we think about CAM Testbed UK, I've mentioned that a few times already. What we're delivering and trying to build in the UK is a set of interoperable facilities which have the full range of capabilities you need to do to take your product from very, very early concept stage in simulation right through to testing early in the real world in safety on a proving ground, through to delivering it at scale, at market, in a real world environment of a living, breathing city. The CAM Testbed UK is made up of 6 facilities: Cavway, Convex, Hariba, Myra, Millbrook, Culham, Midlands Future Mobility, and Smart Mobility and Living Lab. They all have their own unique strengths, and they all complement each other potentially to deliver a cohesive set of services. So we haven't tried to build as one test facility to rule them all. What we've tried to do is democratize this a bit, work with a range of partners across industry to get best practice and knowledge to deliver a set of cohesive facilities that can work together where needed. And when we think about this, in the terms of these 3 pillars I've described, interoperability is the key, and we're on an early journey here to deliver interoperability between these facilities. Convex is a data platform which will be providing a means of sharing data. We all understand that by sharing data and applying algorithms to larger pots of data enables you to deliver insight. But how do you unlock data sharing in the first place? Many companies don't want to share data because they know it has a commercial advantage and they'd rather sit on that. So Convex is a platform rooted in creating business models and incentivizations for value sharing of data. You put data in, you can sell it. You can take data out, you can buy it. Potentially you put data in and you take data out, but you get a reduction on the cost of that for what the data you put in. They're very important to try and break the business models here, or set the business models with a capability like Convex to enable us to have data sharing across these pillars. And these examples on this slide aren't completely the totality of what the capabilities across Testbed UK, but we think about simulation, that vehicle in the loop again. We've got this CAM Testbed UK van. If you look on our website, you can see the Testbed connected videos to talk about the connectivity solutions across Testbed UK. But here's that van in a vehicle in the loop simulation at WMG. And this is in an anechoic chamber. So you can not only test the vehicle in the loop with the simulation, it's an anechoic chamber. So you can test different types of capabilities for signaling in 4G, 5G, roadside units. How do they interact with the vehicle in complete safety? We have the proving grounds capability of Myra, we talked about, and then real world environments. We talked about Midlands Future Mobility and Smart Mobility Living Lab. but also, there's this semi-controlled environment at Race, which is, is a scientific, research facility just outside of Oxford. There's no children or dogs, in there working in that area, but lots of scientists and other things. So we say it's a semi-controlled environment. You can work with the population workforce on that site to design tests and things there, which are indicative of the real world, but still allow you an extra layer of control. And ultimately, what we want to be able to do is move between all of these capabilities. And some of the ways we're doing that, and the interoperability examples I sort of have for how we've been doing that across these facilities in the UK is, first of all, we looked at, how do we have a common language across these facilities around safety? What does that mean? What does a good safety case look like? We've had 2 iterations to date. The last iteration actually became the basis for a BSI PAS 1881, and we're in the process of now developing a much more detailed safety framework, which can be used to create safety cases and also assess safety cases. So that if you are a testing organization, a developer of an automated vehicle solution, you can understand what good looks like to deliver a safety case. And if you are a organization, maybe a local authority that wants to see testing happening on your streets to deliver services, you also understand what good looks like for a safety case as well. So that's the next piece of work we're undertaking here. But we have this signed up to by all the facilities we work with, so that when come to Camp Testbed UK, you know what a safety case could and should look like. Simulation. This is a tricky one. Ultimately, there's a lot of pain points in simulation. It's often a set of capabilities which are almost deliberately stovepiped, because there's quite a lot of margin in being able to charge for bespoke additions for simulation tools and things like that. There's not a lot of incentive in the industry to join these up. But when we think about interoperability of simulation and all the test beds, within CAM Testbed UK have simulation capabilities, how do we draw across a best of breed of those to deliver the frictionless, interoperable, distributed simulations so that customers can get the answers they need quickly? What we're doing now is, we're running a project to test out how potentially we could link the capabilities from a testbed, from a number of test beds, to provide a seamless, customer experience, across a number of different capabilities. And we're looking to implement APIs within that so that the intellectual property maintains it's safeguarded, and it's often a black box, and we don't really say intellectual property. But what you're potentially able to do is run a scenario days from the National Scenario Database at Midlands Future Mobility. You have a vehicle dynamics model provided by Millbrook or Myra. Potentially have a traffic model for London from SMLL, a driving model, a terrain model from the city, and ultimately potentially have vehicle in the loop capabilities delivered by another city. And you can join them up through an interface bus, which we're working with Convex to try and figure out how we design that, so that we can join all these elements up and deliver a single simulation which draws on the best capabilities which we have from all these commercially distinct test facilities. It's a very exciting project. Looking to complete this in March. And any interest in this, do get in touch with us. And then there's also emergent interoperability. What is the Android of the AV world? Really pleased to see this company, Street Drone. We haven't specified this. We haven't asked the testbeds to do this. This is a company based in Oxford. And it is providing its vehicles to Millbrook Proving Ground, to Race, to the Smart Mobility Living Lab, both in forms of the Renault Twizy, but also an EV200. And what Street Drone, built on the AutoWare open source platform. So actually, if you want to come in and you want to deploy your own AI solutions, your own image recognition, you want to put your own sensors onto these vehicles, what you have is a complete capability, a vehicle sandbox to deliver the tests you want. And because these vehicles are available across several of our test facilities, you can also potentially move that capability from one to the other to, again, have a frictionless journey between these facilities in the future. It's a great piece of emergent interoperability. It's great to see Street Drone operating across these facilities. So what does international interoperability look like, or could it look like? Well, let's come back to testing best practice unlocks public acceptance. We sort of established that at the beginning of of this presentation. But also, a shared approach to safety and validation also unlocks common market approaches. And unless we start to think about how safety and validation can be conducted across different markets and benchmarked together, we're going to hit a blocker on, on imports and exports and scaling this market globally. So how about we take this model and we think about what's going on and how we might run some kind of shared approach for safety validation? Well, things are happening, and as we step around this set of capabilities, we can see that, they are for, let's agree the basics. So for simulation, can we agree on shared operational design domains? What does a design domain, having similar between, potentially in Korea and in the UK? I mean, maybe it's parking, maybe it's another scenario, but, can we agree on shared design domains? Can we agree on shared scenarios for testing? Highway driving, is a simple example of something, which is sort of ubiquitous the world over. And then we can think about, also ASAM is also looking at, concepts here for delivery of simulation capabilities for shared scenarios here as well. So, the basics are coming into place. So, how do we build upon those? Again, we've got standards emerging, SAE applying system theoretic process analysis to automotive applications, intelligent transport systems, motorway chauffeur systems under ISO is all being developed now. It's great to see the standards happening. So we've got the basics which are starting to emerge. And then when we think about sort of in the real world environment, this working group on, ITS, AV decision making under IEEE, is led by Intel with Mobileye, BMW, and some other partners participating in that. What you have is an ability to start to agree what does safe enough look like? What are we measuring? How do we implement those measurements in our design processes to agree what safety looks like in different design domains, and what does safe enough look like? So we have the basics. But really what I want to say is what we need to do is start somewhere. And what would be great to do is to look at how we might work bilaterally, multilaterally, with partners across the world to just look at, what is the easiest problem we can solve now to get us to learning. The standards and everything, the theoretic discussions are brilliant, but let's start applying that and let's see if, could we have shared agreed operational design domains? Could we have shared agreed scenarios, which we could put into each other's simulations and see how they perform? Can we start to validate and verify, internationally, and get to a baseline? And the only way you do that is to learn by doing. So we need to move beyond the paper-based studies. We need to move to an agile, cooperative, international learning, and we need to try it and see if it works. And I'd be really keen to talk to anyone who wants to understand how we might move forward together to start this journey of some research and development, rapid prototyping, to see, what can we do to be able to potentially verify and validate each other's technologies in each other's countries, because that's going to unlock trade. It's going to unlock the potential market for connected automated mobility, and ultimately it's going to be the thing that helps us to lead to scale. Thank you very much. I'm Dr. Richard Porter from Zenzic. You can contact us here.